Hello and welcome to Solved, where we help you solve problems. In this video, we will be discussing the material balance of evaporators. Evaporators are one of the more commonly encountered process units, and it's important that we understand how do evaporators work. Here is the problem statement. It is desired to prepare a sweetened concentrated orange juice. The freshly pressed juice contains 5% solids, and it is desired to increase this amount to 10% solids by evaporation. Calculate the amount of water that must be evaporated based on 100 kilograms per hour of fresh juice. Let's go ahead and solve this problem. Here is our diagram for the problem. In general, for an evaporator, we have three streams. We have the feed stream, which is a dilute solution. We have the product stream, which is the more concentrated solution. And we also have the water vapor stream. This water vapor stream is the water or the solvent that is taken out of the dilute stream. In most cases, our evaporate stream is given as a pure solvent. In this case, we can assume that our stream W is 100% water. This is the water that is taken out of your fresh fruit juice in order to concentrate the juice further. If you will notice, we have simplified the representation of the fruit juice in the evaporator. For example, in your feed stream, everything that is not water is represented as a solid. That could include the pulp, the flavorings, dissolved materials, etc. Everything that is not water is represented singly as solids in order to simplify our solution. If that's the case, then we have a binary solution in which we have 5% solids in the feed and the remaining 95% of that is simply water. That is the same case with the product. By increasing the percentage of solids from 5 to 10%, our product now only contains 90% water. Please do take note that the 95% water in the feed and 90% water in the product are not mentioned in the problem. This has to be interpreted as part of the evaporation problem. Okay? So always take note of the structure of the diagram for an evaporator. We have one feed stream and two product streams. In this problem, we are required to look for the value of W, or the amount of water evaporated from the solution to make it more concentrated. With that, we will start with our basis. Since we are given with the flow rate of the feed, 100 kilograms per hour, a sensible basis would be 1 hour of operation. We can now construct our overall material balance, that is, F is equal to W plus P. Remember, we only have one inputs and we have two outputs. Substituting the value of F, that is 100, is equal to W plus P. This is our equation number 1. Next, we will have the component balance. For an evaporator, usually there is a tie component. If you take a look at your components, that is the solids and water, the solids is our tie component since it enters on the feed stream only and exits on the product stream only. It enters on one stream and exits on one stream. Performing the solids balance, we have 0.05 times F is equal to 0.1 times P. We are simply multiplying the mass fraction of the solids to the flow rate of the stream. Since we know the mass flow rate of the feed stream, we can immediately solve for the mass flow rate of the product stream. That is 0.05 times F, which is 100 kilograms per hour, divided by 0.1. Our product stream is 50 kilograms per hour. It's essentially 50 kilograms, but it becomes 50 kilograms per hour because of our basis of 1 hour operation. Now that we know the value of P, you can go back to our overall material balance and calculate for W. So from equation number 1, we say that W is equal to 100 minus P. And with that, we can say that the amount of water evaporated is 50 kilograms per hour. That is how you perform the material balance for evaporative processes. Take note that this approach carries with it its own set of assumptions. That is, the evaporate is pure water and that we can lump everything that is not water in a category known as solids. This form of the diagram is also applicable for direct heating dryers, wherein you have a wet feed And then you pass it through a dryer to get a dry product and the evaporated water or moisture. That's it for this video. Thank you for being here, and I'll see you on the next one.